The quantum internet, our first prediction, moves us beyond the world of silicon and into the subatomic realm. Dr. Kaku states that the 21st century will be dominated by the quantum revolution, and its most transformative product will be the quantum internet. But what does that actually mean? Today's internet runs on bits, ones and zeros. A quantum internet would run on qubits. Thanks to a property called superposition, a qubit can be a 1, a 0, or both simultaneously. This allows quantum computers to perform millions of calculations at once. But the real magic for the internet comes from another quantum phenomenon: entanglement. When two particles are entangled, they share a cosmic connection. Change the state of one, and its partner instantaneously changes, no matter the distance. Einstein called this spooky action at a distance. This is the key to the quantum internet's unhackable security. Any attempt to eavesdrop on a message sent using entangled particles would immediately break the entanglement, alerting both the sender and receiver to the intrusion. It's not that the code is hard to break, it's that the act of listening destroys the message itself. Kaku envisions this not just for sending emails, but for creating a network of quantum computers that could solve problems currently impossible for us. Imagine designing a new life-saving drug by perfectly simulating every single molecule's interaction, or discovering a room temperature superconductor, which would revolutionize energy transmission and transportation, effectively ending our reliance on fossil fuels. The quantum internet is the grid that would power this new age of discovery. Kaku believes we will see the first operational links of this network within the next 10 to 15 years, with a global network being a project for the second half of this century. Human immortality. Perhaps Dr. Kaku's most audacious prediction is that the first person to live to 150 has already been born, and the first millennium-old human may be just a generation away. This isn't about finding a fountain of youth. It's about reclassifying aging from an inevitability to a curable disease, what he calls the moonshot of medicine. He breaks this down into 3 revolutionary pillars. First, the nanotechnology pillar. Kaku predicts we will have a fleet of medical nanobots, smaller than a cell, patrolling our bloodstream. Their job: they will be our internal mechanics. They will scrub our arteries clean of plaque, identify and destroy cancer cells the moment they appear, and repair cellular damage from the inside out, effectively reversing the wear and tear we call aging. Second, the genetic pillar. With technologies like CRISPR and beyond, we will move from treating symptoms to editing our genetic software. We will be able to turn off genes responsible for hereditary diseases like Huntington's or Alzheimer's. But further, we may learn to reactivate the enzyme telomerase, which repairs the protective caps on our chromosomes called telomeres, a key mechanism in cellular aging. Third, the diagnostic pillar. Kaku envisions a smart toilet that analyzes your waste for biomarkers of disease, and a smart mirror that scans your retina and breath for early signs of illness. Your phone will contain a chip that can diagnose thousands of diseases from a single drop of blood. Medicine will become predictive and preventative, stopping problems long before they become critical. The societal implications are staggering. Careers, education, and relationships would be fundamentally redefined. The primary challenge, Kaku warns, won't be the science, but the sociology. How do we manage a world where people live for centuries? The Type 1 planetary civilization. To understand our place in the universe, Dr. Kaku often uses the Kardashev scale, which measures a civilization's level of technological advancement based on its energy consumption. Currently, we are a Type 0 civilization. We get our energy from dead plants like oil and coal. We are, in Kaku's words, a planetary civilization in the womb, still fighting over border disputes and tribal ideologies. But he predicts our graduation is near. We are on the cusp of becoming a Type 1 planetary civilization. This is a species that has mastered all forms of energy available on its home planet. This means a global energy grid, harnessing 100% of the solar, wind, geothermal, and tidal energy that reaches Earth. Kaku is a strong proponent of nuclear fusion as the ultimate clean energy source to power this transition. Planetary engineering. With such vast energy, we could begin to control our planet's systems. We could steer hurricanes, halt tornadoes, and perhaps even trigger earthquakes to release pressure safely. We would no longer be victims of nature, but its stewards, a post-scarcity society. With limitless clean energy, the cost of clean water, food production, and manufacturing would plummet. potentially lifting the entire global population out of poverty. Kaku sees the internet as the beginning of the global nervous system for a Type 1 civilization. However, he gives a serious warning. The transition from Type 0 to Type 1 is the most dangerous period in a civilization's life. We possess the destructive power of a Type 1 civilization with the tribal, fractious politics of a Type 0, overcoming nationalism, and uniting to solve global problems like climate change is, in his view, the final exam for humanity. BrainNet. If the quantum internet is the next step for information, then BrainNet is the next step for experience. Dr. Kaku predicts a future internet where we can transmit our thoughts, memories, and even emotions directly from one mind to another. The science for this is already in its infancy. We have functional MRIs that can see which parts of your brain light up when you think of a star or smell a rose. We have brain-computer interfaces that allow paralyzed patients to control robotic arms with their thoughts. Kaku's prediction is the logical endpoint of this trajectory. He breaks down the process. First, we would need a complete brain dictionary to decode the neural patterns for every sensation, memory, and concept. This is an immense task, but not an impossible one. Second, we would need a non-invasive way to read and write these patterns. Kaku suggests a future where advanced MRI machines or neural dust, tiny sensors sprinkled on the cortex, could act as the interface. The implications are mind-boggling. Education. Instead of reading about the Roman Empire, you could download the memory of a historian who walked through the forum. Communication. You could convey the feeling of love, the awe of seeing a Grand Canyon, or the subtle taste of a fine wine, not with clumsy words, but with the pure experience itself. Entertainment. Movies would be immersive experiences where you don't just watch the hero's journey. You feel their emotions and sensations. This raises profound questions about identity, privacy, and what it means to be human. If memories can be uploaded and downloaded, is a memory still yours? BrainNet, Kaku suggests, could be the ultimate empathy machine, but it also requires us to redefine the very boundaries of the self. Interstellar travel. Dr. Kaku is blunt about our current technology. Chemical rockets will never take us to the stars. The distances are too vast. But he is profoundly optimistic about our potential to get there by bending, not breaking, the laws of physics. He champions two viable pathways to the stars. The first is the near-term path, laser sails. Projects like Breakthrough Starshot propose building a giant laser array on Earth or in orbit. This laser would fire at an ultra-thin, reflective light sail attached to a tiny, gram-weight, chip-sized probe. The laser's photons, while massless, carry momentum and would push the sail to 20% the speed of light. At that velocity, such a probe could reach our nearest stellar neighbor, Proxima Centauri, in just over 20 years. Kaku sees this as the beginning of true interstellar exploration, sending fleets of these nanoprobes to nearby stars to beam back images and data. The second is the long-term dream, the warp drive. Kaku frequently discusses the Alcubierre warp drive, a concept that is mathematically valid within Einstein's theory of general relativity. It doesn't propel the ship faster than light through space. Instead, it contracts the space in front of the ship and expands the space behind it. The ship itself rests inside a warp bubble, within which the laws of physics remain unchanged. Space itself moves faster than light, carrying the bubble and the ship along with it. The catch? It requires a form of matter with negative energy density. While we have observed effects like this at the quantum level, generating it on a macroscopic scale is currently beyond us. Kaku believes that if we can ever master the energy of a Type 2 civilization, harnessing the power of an entire star, this could be the key to unlocking the galaxy. The discovery of alien life. Dr. Kaku has stated with high confidence that the discovery of alien life is not a matter of if, but when, and he believes it will happen within this century. He makes a crucial distinction that is often lost in popular culture: the difference between finding life and finding intelligent life. The most imminent discovery, he predicts, will be bacterial or microbial life. The hunting ground? Right here in our solar system. The oceans of Jupiter's moon Europa, or Saturn's moon Enceladus, hidden beneath icy crusts, are prime candidates. A single mission to drill through that ice and sample the water could, within the next few decades, find living organisms or their fossilized remains. The next level of discovery will come from biosignatures on exoplanets. This is where telescopes like the James Webb and its successors come in. As an exoplanet passes in front of its host star, a tiny fraction of the star's light filters through the planet's atmosphere. By analyzing this light with a spectrograph, we can identify the chemical fingerprints of gases in that alien air. The holy grail would be finding an atmosphere out of chemical equilibrium. For example, one rich in both oxygen and methane. On Earth, these gases rapidly react with each other unless they are constantly replenished by living processes. Finding this combination on a rocky exoplanet would be the strongest possible evidence for life. Kaku is far more cautious about intelligent life. While he believes it almost certainly exists, the distances and timescales of the cosmos make contact incredibly difficult. He often references the ocean analogy. Our galaxy may be teeming with intelligent life, but we are like fish at the bottom of a dark, murky ocean, unaware of the other civilizations that may be just a few feet away. The discovery of a simple microbe on Mars, or an exoplanet, would be the most monumental discovery in human history, forever answering the ancient question, are we alone? It would tell us that life is a cosmic imperative, and that the universe is in fact a living place. What was your favorite Michio Kaku prediction? Let us know in the comments below. We read every single one. If you want to be part of the conversation and explore more tomorrows today, hit that subscribe button and ring the notification bell so you don't miss our next journey into the unknown.